In this video, we're going to take a look at control variables in some more detail and do another practice problem together. So remember that when you're doing a control experiment, you have to make sure that your test is fair. You have to make sure that you're changing only one independent variable at a time. If you change more than one, then you're not sure if your independent variable is causing it or other variables that you change by accident. So all other variables, they have to remain the same or constant. And those are called control variables. So let's go back to our coffee scenario from before. Let's say that you were doing this experiment, but you forgot to tell people that on day one, there were other things. On day 1, 2, and 3, there were other things you changed. So let's say on day 1, you had 1 chocolate bar in addition to your coffee. On day 2, you had 2 in addition to your 2 coffees. And on day 3, you had 3 chocolate bars in addition to your 3 coffees. Can you still really conclude it was that the more cup of coffees that you would drink, the later you'd stay up? Think about that for a bit. Discuss it. Think about it in your head. Write down a response. Pause the video. Now that you thought about it, maybe you realize that you can't really conclude that confidently anymore. Was it truly the coffee, or was it the chocolate causing you to stay up longer? So that wasn't a controlled experiment. Now you don't know if it was your intended variable that you were changing, the coffee, or if it was the chocolate you were also changing but you didn't realize it, that was causing you to stay up longer. So that means to make this experiment better, you should have probably either eliminated the chocolate altogether or just made sure that you always had the same amount of chocolate bars every day. So if it wasn't changing, it wasn't the one responsible for causing your dependent variable to change. So that's what a control variable is. So in the coffee experiment, we could think about control variables. For example, you might say flavor of coffee. So flavor. I'll put CV here. You might say diet on the day of, right? You might say amount of activity you had during the day. You might say maybe amount of TV that you watched. So there's so many other variables that can maybe affect how long you stay up that you have to keep the same. Otherwise, you won't know if it was that variable or the coffee that's causing you to stay up longer. So let's go to this scenario here, and we're going to try to identify all the variables that we can. We'll make a table as well. So all the skills that we previously learned, we're going to apply to this one question. And this is the type of questions you could see on quizzes, tests, assessments, labs, where you're going to have to figure out where your variables are. And when you design experiments, you actually come up with your variables so that you can actually design experiments around the variables that you came up with. So Gardner wants to see if what amount of water is the best to grow plants. Her guess is that the more water the plants get, the more they will grow. For one of her plants, she uses 50 mils of water per day. For another, she uses 100 mils. For another, she uses 500 mils. At the end of the experiment, she measures the height of each plant and found that the 50 mil plant was 10 centimeters in droopy. The 100 mil plant was 15 centimeters in droopy. And the 500 mil plant was 18 centimeters and firm. So let's go to our variables. We saw that the scientist was changing the amount of water. So the amount of water is our independent variable. Amount of water, and the amount was measured in milliliters. The dependent variable was the growth of the plant. So growth of plant, and you could have said plant height as well, because that's what the scientist measured, plant height. And that was measured in centimeters. Now before we go to the guess being correct or not, let's go take a look at the 2 control variables. So the scientist wants to just test the amount of water. So we have to think of some variables that could affect plant growth. So we need to make sure they stay the same to make sure we're just really testing out the amount of water here. So you can pause the video and think of some. Here are some that you might have thought of. So maybe you might have thought of amount of sunlight. So you would write amount of sunlight. I'm just writing sunlight here so I have room here. Amount of sunlight. Maybe you might say type of soil, so soil type. Maybe you might say type of plant, because that could affect it. That should be the same between all groups. Maybe you might say, so we said sunlight, soil, type of plant, maybe the temperature in the environment might affect it. So these are all different examples of control variables that you could have written down. I asked for 2 here, but the more control variables you have, the better your experiment's going to be, because you'll know that you're truly just testing the amount of water and nothing else. Maybe the initial height of the plant you might want to look at as well. So those are all things that you'd have to look at. If you have a pot of plants, maybe there's only 1 plant per pot. If you have some pots that have 2 plants versus 3 plants, now you have too many plants in one pot compared to another, that can affect the growth too. So there's so many things that have to be kept the same that you don't even realize until after you start the experiment. That's why it's important to actually think about your experimental design before you actually conduct it. So you do have to think about it quite a bit, and even after you're done doing your experiment, you have to go back and analyze, was there anything else you could have done better? So was the guess correct? Well, the guess was that the more water, the more they will grow. And so we saw that the plant that seemed to grow the most was the one with more water. So yes, it was supported. Okay, so now we're going to go and we're going to make our table. So remember that we always have to have a title. So I wouldn't put the word title, I'd put table. This is our second table we're doing here. So I put table 2.0. The effect of amount of water, that's our independent variable, on plant growth or plant height. So in the first column, I'd put amount of water. I would put my unit in milliliters. And then I think I had 50, 100, and 500. So 50, 100, and 500. Notice I'm not writing milliliters because I wrote it down over here. Our dependent variable, the more quantitative one, was the plant height. And that's in centimeters. And I would do, let's see, 10, 15, and 18. And our other observation column, it looked like it was more perhaps the firmness of the plant. So how firm it is, it's more qualitative. Firmness, or you might say strength of plant. So we had droopy for the first 2, but then firm for the one with 500 mils. So notice we had a more qualitative descriptor in that third column. So what we saw is how to identify the independent variable, the dependent variable, to see if guesses were correct or not. You might remember what a true, the scientific word for guess is in the scientific experiment. It starts with an H, correct, hypothesis. We'll see more of that later. We saw how to identify control variables, the more the merrier. We saw how to make a table with the proper title, the effect of IV. Here's my IV, amount of water, on DV, plant growth or plant height. We put the independent variable in one column, dependent in another, dependent qualitative in the other, and then we wrote the data down. Now that's just one type of observation table. Keep in mind that in reality, when you do a true experiment, an experiment does have multiple trials, right? Multiple repetitions, because one trial is not enough to really be reliable, right? If you flip a coin, twice and you get heads twice, it doesn't mean it'll always land on heads. You have to flip a coin many times. So what you would do typically is you would make a table that looks more like this. So if you do have multiple trials, you would write your independent variable. So for example, let's say it was the amount of water, and you would record your dependent variable here with 3 columns for the trial 1, trial 2, and trial 3. And then you'd have to decide, well, which trial am I using for my data? Well, you'll see a term here called derived quantity. And so derived quantity, that simply means the average, right? That's where you add up all the trials and divide by the number of trials. So let's say for the 50 mil trial, you had 3 pots of plants and you got 3 results. You got 10 for trial 1, 12 for trial 2, and then 14 for trial 3. Well, what you do is for 50 mils, you wouldn't choose the 10, the 12, or the 14. You would take an average. So you would do 10 plus 12 plus 14. That would be 22, 36. And then you would do 36 divided by the number of trials. There's 1, 2, 3 trials. And that would give you an average of about 12 centimeters. So that would be your average plant height for the 50 mils situation. And so that's the number you would use in your data point when you're making your conclusions, the average plant height. And in reality, you'd have a lot more than just 3 trials. You have multiple trials. You could have hundreds, thousands of repetitions and trials depending on your experiment to be a more reliable experiment overall, statistically speaking. And so that's how you could make a table using averages and derived quantities instead. So in the next video, what we'll do is we'll go over a practice problem together, the practice quiz in your handout here. You can try it ahead of time and then check your work. The only difference with this practice quiz is there's a table where you might have to make an average instead, use an average instead. You can try the learning goals here. To complete the learning goals, all you need to do is go through your slide deck and then just make sure you get all the definitions down properly, you understand it, and you do some of the practice problems for the scenarios in the tables over here. You can compare answers with your peers and just make sure you're specific, and that should be sufficient practice for identifying variables that are independent, dependent, control, and also making observation tables.